is all about independent events. This is just, there's an investigation that is in your book if you want to work through this to kind of show you the correlation between independent events. Um, Basically, two events are independent if the occurrence of each event does not affect the other. So if you have an independent events, this is the formula. If A and B are independent, then probability of A and B is just the probability of A times the probability of C. So depending on how many events there are, if there are 3 events, you just multiply all 3 of them. So a coin is tossed and a die is rolled simultaneously. So what you flip on your coin has no bearing on what you roll on the dice. Determine the probability without using a grid. So we want to look for the probability of head and 3. Remember, this is the symbol. The intersect is the symbol for and. So this is the probability of a head times the probability of a 3. So what's the probability of rolling or flipping a coin and getting a head is 1/2 times the probability of rolling a 3 is 1/6, which means the probability of flipping heads and rolling a 3 is 1 out of 12. Okay, Carl's not having much luck lately. His car will only start 80% and his motorbike will start 60%. Draw a tree diagram. So the first thing that's always helpful is to decide how you want to label or mark. Let's say C equal car starts and M is motorbike starts. All right. So the first thing that we want to do is look at the car. And the car either starts, and so we're going to call that car, oops, I don't want it there. We'll call this car starts and car does not start, not car starts. If his car starts 80% of the time, the probability is 0.8. So the probability it would not start, remember complementary events always equal 1, would be 0.2. Because you're in a tree diagram, your arrows always have to add up to a 1. Then from here, we're also going to look at the bike. All right, so we say that M starts or M does not start. Or we're also looking, what if the car does not start? What happens with the motorbike? It either starts or it doesn't. So this is all the different possibilities if he starts both the car and the bike. What will happen? Since the motorbike is 60, starting is 0.6, not starting 0.4, and that will be the same for this particular diagram. So when you calculate probability on a tree diagram like this, you just multiply straight across. All right. So this is that both the car, let's write it this way. Probability car and motorbike starts. Notice that's this one here will be 0.8 times 0.6 for a probability of 0.48, 48 100ths. All right, so this is letter A, letter B. Carl can only use his car, so that's the car starts and the motorbike does not start. So the probability the car starts, we're following this. So we're going to follow car starts, motorbike does not. So we're taking our 0.8 times 0.4 to get 0.32, 32 100ths. Notice each time I'm labeling the probability with the correct notation and the final answer. So it's really important that you're documenting all the way through exactly what you're finding. That's going to help you. All right, example 16, Liam rolls a 6-sided die twice. Determine that the probability is exactly 1/4. All right, so the tree diagrams are really helpful for something that you're doing, that you have 2 pieces involved or twice. So let's say, let's just call it A is rolling a 4. As long as you define or identify, that just makes life a lot easier. All right, so this is the first roll. You either roll a 4 or you don't. Then there's the second roll. You either roll a 4 or you don't. You have to do that for each event from the first time. So then here, if we roll a 4, that's 1 out of 6. If we don't roll a 4, we have 5 chances out of 6. Then 1 out of 6 rolling a 4, 5 6 does not. Now, if we look at this, so this is rolling a 4 twice. If we follow it this way, if we go up and then down, that's A prime, or we could go down this way, A prime, A, and then A prime, A prime. So exactly 1/4 is this one, because I have exactly 1 here, and this one. So the probability of rolling a 4 is A prime plus A prime A. All right, so A prime, A prime is 1/6 times 5 6. Or we also could have A prime, not a 4 first, and then rolling a 4, 1/6. Oops. We get 5 out of 36. And there's 2 different cases that could happen. So that gives me 10 out of 36, or divide both by 2, and 5/18. All right. So you can always leave it as an exact answer with a fraction. I would always say just do that. If they're giving you decimals like up here, then you just leave it in decimals. Always go 3 sig figs if you have that. These are exact answers. And that's done.